Hello everyone. Today I'm going to teach you about the chemical bonding in the some most common structures that are accompanied with us. So here I have divided the page in some columns. The first is the number of bonds, then type of hybridization, geometry, shape and bondage. And I have further divided the number of bonds in two parts, that are lone pair and bond pair. The first thing that you are seeing is bond pair 2 and lone pair 0. So the hybridization would be sp. The geometry for this hybridization is linear, which could be represented as and its shape is linear. Bondage is 180 degree angle. This angle is 180 degree. If we have three elements, so A would come here and one bond pair here and another bond pair here. So see, we have two bonds, one bond and two bond. The shape is linear and the angle is 180 degree. Now again, if we have three bond pairs and zero lone pair, in this case the hybridization that we have is sp2. The geometry here will be trigonal planar, that could be represented as A, B, B, B. So here the angle is 120 degree. This angle is 120 degree. We call it as triangular planar. The bondage angle, as I've already told you, is 120 degree. Now moving on, if we have four bond pairs, okay, and the hybridization will be here zero lone pairs, the hybridization will be sp3. In this case we have tetrahedral shape, that could be shown as like this. Sorry, here we have the angle is approximately A, this is B, 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 B. The angle here is 109 degrees 28 minutes, and this shape is known as tetrahedral. Okay, this shape is known as tetrahedral. Now good see it, just have a recapture of it, everything. Okay, now in this case we have two things. First, I have shown you the sp3 hybridization, and another one is dsp2 hybridization. dsp2. The difference between the both of these hybridization is that in this hybridization the bonds which are used are s plus px plus py plus pz, but here we use s plus px plus py, and the d orbital which is used is dx square, okay, dx square y square. This is not known as dx square minus y square, it is dx square y square. Okay, then the shape here is like this. Here A, B, 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 and we call it as square planar. Square planar. The bond angle is 90 degrees. Okay. Then okay, we'll show it as 40. Okay. Now I'm going to tell you about the bond pairs. If there are 5 bond pairs and 0 lone pairs, in this case we have D. Okay, it is sp3d. It is known as sp3d, which is known as trigonal tri trigonal bipyramidal. It is represented as like this. These are known as the axial bonds, and this is known as equatorial. Okay, here it is A, it is B, 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 and B. This shape is known as trigonal bipyramidal, and the angles, here we have 2 angles. This angle is, we could see, is 120 degree, and this angle is 90 degree. So we have 2 angles, 90 degrees and 120 degrees. Now if we have 6 bond pairs, 0 lone pairs, the hybridization that we will get is sp3d2. I would like to tell you that in this we have s plus px plus py plus pz, okay, and dz square. Okay, in this we have s plus px plus py plus pz plus d x square y square, and I've already told you this is known as x square y square and not as x square minus y square, and dz square. The geometry here is square bipyramidal or octahedral. What is it? It is square bipyramidal or octahedral, and it could be shown as like this. We know we have 6 bond pairs. Here will be A, B, 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 B. Again, these are axial and these are equatorial. Okay. Now, as we could see, the angle here is 90 degree and this angle is also 90 degree. So we have just one angle, that is 90 degree. The last category is 7 bond pairs, 0 lone pairs. These are known as sp3d3, and it could be shown as s plus px plus py plus pz plus dx square y square, dz square plus dxy and dyz. Then the shape, it is known as pentagonal bipyramidal. It is represented as A. Here everything is B, 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 B. Okay. Here we have 2 categories of angles. This is 72 degrees and this is 90 degrees. So 2 angles, 90 degrees and 72 degrees. Now we'll again just have a look overview. I'm just going to tell you. See, 2 bond pairs, hybridization is sp. The p orbital may be px, py or pz. The geometry is shown. The angle is 120 degree. The shape is linear. 3 bond pairs, we have sp2, s plus px or py or pz. Any 2 could be used out of 3. Here we have trigonal planar and bondage is 120 degree as it is shown. Then we have 4 bond pairs. It is sp3. All the p orbitals are used and it is tetrahedral. The angle is 109 degree, 28 minutes. Then 4 bond pairs, 0 lone pairs. It is dsp2. Here s plus px plus py and dx square y square. The shape is square planar and the angle is 90 degree. Then we have 5 bond pairs. It could be sp3d. It is s plus px plus py plus pz and dz square. Here we have trigonal bipyramidal shape and the angles are 90 degree and 120 degrees. Then we have bond pairs, 6 bond pairs, and the hybridization is sp3d2. The shape is square bipyramidal or octahedral. Now here we have only one category of angle, that is 90 degree, and again it is bond pair 7. This is known as sp3d3 and the shape is pentagonal bipyramidal and the angles are 90 degrees and 72 degrees. You could even refer to this in most of the textbooks of the class 11th. Okay, now my name is Lovy Bansal. I will come back to you with more videos. Okay, you could subscribe this video and thank you.